I'm actually going to be hosting the first session, our opening session to kick us off. I'm going to be joined by the co-chairs of AIUK and the Turing Institute's new Chief Scientific Officer, and we're going to be talking all about biggest discoveries in AI and kind of getting a little bit of a view from the bridge to kick off today's conference. But let me introduce each of you first. Let's start with Professor Michael Wooldridge. Mike's Professor of Computer Science at the Department of Computer Science at University of Oxford, a Senior Research Fellow at Hertford College and a Turing AI World-Leading Research Fellow. From 2014 to 21, he was the head of Department of Computer Science, and in 2020 he was awarded the Lovelace Medal from the British Computer Society. He's also co-director of the AI programme at the Alan Turing Institute. Joining as co-chairs, Professor Rachel Franklin. She's Professor of Geographical Analysis, the Centre for Urban and Regional Development Studies, that's quite a long title there, and the School of Geography, Politics and Sociology at Newcastle University, and the University Lead for Newcastle at the Alan Turing Institute, where she's also a Fellow. Her primary research focus is in spatial demography and the interplay between spatial analytics and demographic change, in particular quantifying patterns, sources and impacts of spatial inequality. Amazing. And finally, I welcome Professor Mark Girolami. Mark is a chief scientist at the Alan Turing Institute, took up his role in October 2021. Previous to this role at the he was chief scientist. He led Alan Turing Institute's Lloyd Register Foundation programme in data-centric engineering, which launched, I hear, a whole new discipline that has global reach and influence. Amazing. What a brilliant panel to kick us off today. So let's start with a question that's actually quite close to my heart, considering I'm very interested in hype and boom and bust cycles. Obviously, AI, as we all know, and probably everybody watching, has had quite a turbulent history. 1 minute, everything seems rosy. The next minute, everyone's disappointed and bitter and saying it's all rubbish. We've seen this in the early 1970s with the infamous AI winter, and then at the end of the 80s with the end of the expert systems boom. And of course, neural net researchers saw it when their area went out of fashion in the 1990s. Are all these days truly over? I mean, is this just another boom and bust cycle that we're currently in, or are the days of wine and roses here to stay? If things are different this time, why so? Mark, let's start with you.
Well, I think that the previous winters were really in large part due to unrealistic expectations. Expectations by investors, expectations from industry, business, governments and society in general. And in fact, I remember in the 1990s at IBM, we invested quite heavily in AI technology for manufacturing capability. And we saw the deployment of the latest and greatest AI technology to control machines, to control big production processes. And it didn't work. It didn't deliver. And what we saw was the replacement of shiny robots, shiny computer vision systems by rows and rows of manual workers that could do the job that the technology wasn't able to do. And the problem was, of course, that the IBM executives had unrealistic expectations of the technology. And of course, those unrealistic expectations had been fueled by the hype and the smoke and mirrors, as you mentioned, from the marketing claims by technologists and also by the probably over-enthusiastic scientists, I would say. So yes, the unrealistic expectations definitely are in large part the feeder of these booms and busts, and as well as the unrealistic claims by the technology and the scientific community. So both of those together feeding off each other. But if I think now, we are now in a boom, an AI boom, and there's renewed enthusiasm and anticipation, and the ever-present hype is still here as well, surrounding the sort of latest AI technology that we're seeing, which is primarily deep neural networks, and we can discuss that a bit more. But the range of the use cases of deep networks have been really, truly revolutionary and expanding beyond language modelling, image analysis, And we're going to really important and groundbreaking and societally important applications such as medical imaging, medical diagnostics, driverless vehicles, and weather forecasting. And the possibilities seem almost limitless. But of course, there's a danger that everyone gets carried away with the hype that surrounds things like generalized AI and rampaging robots, the displacement of human endeavour and so on. But if we lay aside the sci-fi, then these AI technologies that are emerging from deep nets and other AI areas of science, which I'm sure we'll talk about, the specific use cases are showing remarkable potential, but they still need to be developed into mature, robust technologies that are fully understood and trustworthy. So if we think about the basic theoretical understanding of deep networks, it's still lagging way behind its usage and the possible adoption. And I think if you think of the telecoms industry never used nonlinear filters in their systems. Why? Because they didn't know what the theoretical properties were. They didn't know if they would break down, when they would break down, when they would malfunction. And they always stuck with linear filters that the theoretical properties were well known and so they could be trusted in any large-scale deployment. So, are we in another boom and bust cycle? I would say that the global investment in the expectation for deep network technology and the expectations of national governments across the world means that expectations are again high, and the bets this time are really big. But I would say that this time the scientific community, the technology development community, is much more circumspect. And global scientific leaders, and we'll hear from Mike, in AI, are very seriously grounded in developing the science much more rigorously. The AI research community, I would say, is probably one of the most self-critical of the sciences, and this is good and healthy in terms of avoiding another bust and feeding another boom. And if one reads the UK's national AI strategy, there's a real acknowledgement that AI is a useful term for a set of technologies that have the potential to be transformative. And that reflects a much more measured and grounded expectation from government. So the technology this time round seems to work in certain cases, and there's lots of broad applications. The expectations, I think, are tempered and are cautious more generally. And the scientific community is much more cautious and realistic. So you said, are we entering a time of wine and roses? No, I don't think we are. I think it's more a time of blood, sweat and tears to get these things really working. But I think that's a much more promising place to be in avoiding another boom and bust cycle. Mike?
No, I absolutely wouldn't disagree with any of that. So if I look back at the causes of the boom and bust cycles that we've seen in the past, I think you're absolutely right, unrealistic expectations. But what I would say is what people did is they would try a new technique on a toy problem, and they would demonstrate, for example, that they could build a system which could learn, or that they could build a system which could solve problems, which are components of intelligence, and then just assumed it would scale without any difficulty. And, it didn't scale, basically, is the story time and time again. So if we go back to the 1980s, there was an expert systems boom in the second half of there was a neural networks boom in the second half of the 1980s. And there were a bunch of techniques that were introduced then, which are the same techniques, more or less, that we use today. But at the time, they couldn't make the neural network scale. They could show that these were working in principle, on problems, that they had promise, but they couldn't make the technology scale. And why couldn't they make it scale? What we needed, as it turns out, were there were some scientific advances, the deep part of deep learning, which arrived around about 2004, 2005. But actually, lots of data and lots of compute power was required to make neural network technology scale. So I think that's what's driven the current boom, is that we can make that technology scale in a way that it didn't scale previously. But I think you're absolutely right, and we do need to be very careful about unrealistic expectations. There is this assumption that you can move from an experiment in the lab to demonstrating that this thing looks like it's doing something really interesting to, we can just install that in our business practices, tomorrow, and it's always much more complicated than that. So we are in boom times. I think there's no question about that. I think, will it bust? I think there might be a gentle deflation of expectations as we get a much more realistic expectation of exactly where the technology is going to go, what the limitations of it are, what use cases it will really work on versus those that are going to need more work. But I think what's different this time is we've really seen advances. We've seen advances on problems like automated translation, and usable automated translation, for example, which I think is one of the wonders of the modern world, which is taken for granted by everybody, and they complain when it gets little things wrong. But usable automated translation is an ancient dream of humanity, right? And it's been delivered by contemporary AI. So there are systems like that which just demonstrate the incredible value of this technology that we've developed. And so I think we have delivered in terms of substance, and I think that's what's different. Those automated translation at the turn of the century felt like it was a long, long, long way in the future, and we've now got that as an everyday tool used by millions and millions of people across the planet successfully every day. So what's different this time? I think it scales. There is substance there. So I don't think it's going to be a bust in the same way that we've seen previous busts.
Rachel, is there anything you want to add on this? I mean, I'm thinking about, we've both talked about scales and applicability. Obviously, you're really thinking about how these technologies are being utilised in specific areas. I mean, with your focus on kind of urban and whatnot, how do you sort of see the hype and the narratives around it when it comes to application?
Yeah, well, a lot of this is narrative. I was just thinking, as both Mark and Mike were talking, that I'd like to make a plea for unrealistic expectations.
Okay.
Actually, I mean, it's unfortunately, it does contribute to busts, but it also, that I think, sort of across the board, both in research and in industry and regular life, it's what pushes us to the edge. It's where we identify the gaps of where we would like to be next, right? And so, unfortunately, when we talk about booms and busts, the booms aren't happening in isolation. They're happening in concert with business cycles. They're happening in concert with the regular sort of pendulum swings of society and societal change, right? And so I think it's unavoidable to sort of to have a little bit of a bust. But when you look at these boom and bust cycles, I'm going to use my hands, but it's not like we return to baseline at the end, right? It's like scaling little slopes, and each time when we bust, we're a little bit higher than where we were before. And so I think that's cause for hope. I do agree with both Mike and Mark that I think the stars are aligned now to make things a little bit different, right? I mean, never before has sort of, I think, all of society in every arena been thinking about AI. AI is everywhere. Everyone has something to contribute to this conversation. The scalability issue, the data issue, we have all of these things now that we didn't have the last time we faced a bust. And I don't want to think about how old I was the last time we faced a bust. I cannot contribute to that piece of the conversation very well. But I have a lot of cause for hope sort of going forward. I think if we can work out a lot of the kinks, and I'm sure they will talk about some of those challenges. But I remain hopeful.
And I mean, it's having these kind of conversations too, right? You're saying about it, there's a call for unrealistic expectations. Yes, if everyone in the conversation understands that it's an unrealistic expectation as opposed to something that's a claim. And I think it's being able to have these discussions and get into the weeds of what we think as the leaders are the right things to be talking about and where we actually are as opposed to where we're claiming to currently be is key.
Well, and just to pick up on that, and maybe everyone else wants to say something about this, but I think sometimes once we get into, especially in terms of applications in the real world, whether it's policy or business applications, there are these unintended consequences that we didn't really see coming, right? And so, examples are boundless,
yeah, exactly.
right? And so then I think that's actually where the challenge of the unrealistic expectations is that, oh, well, we hadn't really thought about what this would mean if we were to apply this technology in this way. Any sort of application in the policy or human domain, I think, falls into that category where we didn't really realize what would happen if we, trained algorithms on particular data sets. Well, now we know, though. So we can talk about the downsides, but I think there are also sort of considerable upsides of what we learn as we go.
Definitely. And actually, why don't we later, we'll park that for the moment because I'd love to talk a little bit about obstacles. But let's first get a bit more information on kind of what's happening right now before we get into some of those challenges. And kind of sticking with this theme of the current boom, what people are excited about, what people are talking about, it seems that the current boom, as it were, is about deep learning and specifically neural nets. It seems that the success around neural nets has got everybody quite excited in various different areas. Beforehand, it was more symbolic AI. Is that still relevant? Where are we kind of at with what it is that's really exciting people right now and where the focus is, what we should be kind of getting really excited about, what should we be kind of consigning to history, shall we say? Let's start with you, Michael.
Yeah, no, I think that's an absolutely fair comment to make. And, the history of AI is the history of two strands, which is symbolic AI and neural AI, both of which have kind of come in and gone out of favour. And there's been tension between those two communities at times. And they've both proved, I think, to be successful in different types of problems. So I think they both have things to offer. So the way that I always think about this is in symbolic AI, what you're trying to do is you're trying to model the mind, conscious reasoning process, conscious problem-solving processes, whereas neural AI is more like modeling the brain. I mean, that's not exactly, we're not trying to build artificial brains, but it's using inspiration from the microstructure of the brain and the nervous system. And symbolic AI proved to be good at some things, but there were some challenges, like the big challenge of perception, understanding, where you are and what's around you, which is the core problem you need to solve, for example, for driverless cars, right? Symbolic AI really didn't prove to be very, very good at that. And it's in challenges like perception, in particular, that neural AI has proved incredibly successful at over the past 15 years. And we've got this magic tool, and it's quite an accessible tool. The software support that we have for it is incredible. It's quite easy to build systems that use neural AI, and they seem to work. But we don't understand in any really deep way why they work. And that is a kind of, that's an issue. That's a slightly uncomfortable issue, I think, about current neural technology. It works, it seems to work, but we don't really understand in any deep sense why it works. And at the same time, when it goes wrong, it can go wrong in very, very odd ways and very unpredictable ways. So there are these famous examples of, you can take an image of, a giraffe and you can make tiny little changes to the image, which are undetectable to a human being, where all of a sudden it thinks it's a panda, right? An AI system thinks it's a panda. It would have recognized a giraffe, tiny little changes, and it thinks it's a panda. And that's kind of bizarre and uncomfortable. And that does mean that, I think we've got a way to go before we can be comfortable using this technology in a lot of applications, in sensitive applications, because it goes wrong in unpredictable ways, and we just don't really understand why, in a deep sense, why it works. Yeah.
Mark, do you want to add anything to that?
Yeah, I think the deep neural net technologies are founded on three key components, which Mike mentioned. The first one is data. And if you go back to the days when government and lots of people were talking about big data, it was almost the precursor to the explosion of capability in deep neural networks. The amount of data that we can gather, that we can curate, that we can use is way beyond anything and just keeps growing on an annual basis. And having that data allows us to learn complexities about whatever that data is describing that we never were able to learn about or infer previously. So having data and the tools to manage that, incredibly important. Mike also mentioned computing. we are just seeing advances in the development of new processor architectures, computer systems, new types of language, and even socially, and the way communities are developing and sharing in a federated way software. All of that coming together is really bringing, and of course, the development of smart algorithms. Now, of course, the development of the smart algorithms enables us to do all of this deep learning and demonstrate it in an experimental way. What Mike said is that we don't understand why it works. And so if you think of data, if you think of smart algorithms, if you think of computing, there are three basic underlying sciences there. There is the mathematical sciences giving us the algorithms and giving us the insight as to how these algorithms work, how they don't work, what we can expect from them. The statistical sciences and how we gather data, how we analyse data, how we model data. And then the computing sciences, giving us the compute, giving us the programming, the software power. And I think what we're seeing is as a rallying together within the scientific community of seeking to address some of these emerging issues. Deep learning works fabulously. When it fails, it's almost catastrophic. Why is that? What is this sensitivity? What are the mechanisms? And so globally, mathematicians, statisticians, computer scientists, engineers are all working to fill in these gaps. And so I think this is really, really exciting. So that's the deep technology. The symbolic AI is just as exciting as well in many cases. And Mike focused on the reason for studying symbolic AI, because we want to understand about cognition and reasoning and so on. Looking at it from a more technological perspective, the symbolic systems such as agent-based systems and so on are now allowing us to start to think about the public policy problems, the wicked problems, the really complex problems that can't be framed in terms of recognise this object out of a gazillion and one objects, but the very complex problems that are driven by radical uncertainty that we see in economics and public policy and so on. I think that's a really exciting area that we're going to see big advances in pretty soon as well.
Do you want to add anything on this topic, Rachel, or should we?
No, only to say that I'm just reminded, hearing both of them talk, that this is, I think, a case for the marriage of basic research and applied research, right? That you don't get one without the other. And the open science, and I think the building of communities, it's a very complex puzzle of units that are working together, a lot of which is represented in the program over the next couple of days. So that's my plug for the sessions to come.
And I'm going to plug as well, because of course, being in science technology studies, I'm in the social sciences, so I'm going to plug. Are you going to say something about that, Mike?
So what I guess I didn't address, which Mark began to, is what is the future of these two things? Are they going to, for example, symbolic and neural AI, is there ever going to be a kind of a reconciliation? We use symbols, we're using symbols now, we're communicating in symbols, we're communicating in words, and that's clearly, I think, unambiguously an important part of intelligence. So at some point, neural AI needs to engage with that. I think the big question is whether it will engage with symbolic AI in the way that symbolic AI was developed, or whether there will be a new manifestation of symbolic AI which arises from the neural world. I would bet that it would be the latter, I think. I think there will be a new way of thinking about symbolic AI, which is how how it will be manifested in the neural AI world. And of course, many people are thinking about that issue, but there are no clear answers yet. Lots of fundamental research to do.
I'm going to ask you one more question before we start going, because there's loads of audience questions. Thank you so much for submitting. So we're going to actually go straight to audience soon. Before we do that, we're going to have a poll with the audience. And the question is, what do you think is the most impactful discovery in AI over the past 10 years? So put your answers in. I'm going to ask the panel a similar question, and then we'll go to see what you all said, and then we'll get to some of your questions. So yeah, what are your, we mentioned already a few, you mentioned translation, for automated translation already, but for each of you, quick answers. What are the most exciting AI developments you've seen over the past few years, and why, and then we'll go to some audience. Rachel, I'm going to start with you because you look nervous.
No, well, I'm not nervous. I was just thinking when we started discussing this topic, I was thinking actually it's the everyday interface for me that is most remarkable. That I wake up in the morning and I switch on my phone like most people, and I have a look at what's going on. And just this morning, it's my wedding anniversary, and I wanted to find a photo of me and my husband. And my phone can do that for me. I just tell my phone, find all the photos of this person, find all the photos of this person, give me back what has both of us in them. And it does it super quickly. Yeah. And I think this is remarkable. I could never do this myself, right? So it's actually the everyday ways in which AI works. And we talk so much about where it fails, and I find those equally amusing generally, the giraffe and the panda. But I think we don't talk enough about like how life has become so much more fun and pleasurable and useful and efficient because of these very simple technologies that underpin so much of what we do every day.
Definitely, and I'm just going to double check. I'm just having a look. I don't see the poll live quite yet, so it'd be great if we could get that poll live for the audience so that they can put in their answers as well and their thoughts around the most impactful AI in the past 10 years. But I agree with you. I think that the simple is there, but also I think, and again, I'm going to plug the social sciences. It's where the social sciences come in, thinking about, well, what does it actually mean for society to integrate with these technologies? What does life look like when we do have these technologies that work and are part of our everyday? Mark, I'm going to go with you. What are you most excited about and why in terms of development in the past couple of years?
Mike actually mentioned it. I think language processing and the ability to learn the complexities of grammars, languages, the translation of those languages is just stunning, and it underpins what we have in our phones, what we just expect and just use for granted. But the technological leap that was made is absolutely stunning, and so the impact that it's had. But again, both the scientific and technological leaps that have been made is for me, I think, absolutely amazing.
Do you want to chuck another one into that?
Well, I'm going to be very lazy, and I'm going to give the textbook answer. And this is the point at which people really realised that deep learning was working, and that was 2012. And there was an annual competition, ImageNet, around identifying images and figuring out what's going on in images. And in 2012, there was a system called, I think it was called Alexnet by Jeff Hinton and his students, and there was a step change in that year. They've been having this competition for a number of years. There was just a step change in what they could do, and it was a light bulb moment. It was remarkable, and it was clear that there was something new going on there. And I think that's the point at which people really, really woke up to the potential of deep learning in particular.
We've already had quite a few responses on the poll, so maybe we'll shut the poll and see what some of the audience think. Sorry if you were typing in your answer, you just have to be a little bit quicker next time. Let's see some of the interesting answers we've had. Hopefully they will come up on my screen at some point. Maybe I need a different login, but we'll work that out. Before we get these answers, why don't we go straight to audience questions? The top question, which I think we've touched on a little bit, but it's got 12 votes, so let's go to it anyway, from Anna. What's the biggest misconception in AI trends right now? Obviously, we were talking about hype and whatnot earlier on. Mike?
Yeah, I think the biggest misconception, and this is really ubiquitous, is that we see, like, we've got AI programs that can play chess at kind of superhuman level abilities, and that phrase is superhuman is trotted out really quite a lot. You know, we've got chess programs that can basically beat any human being for all intents and purposes, and now we've got Go playing programs and StarCraft programs that can do those things. And what that tempts us to believe is that we must be on the edge of some kind of wider AI intelligence breakthrough. And what we're getting is systems that can do one tiny little thing incredibly well, but that doesn't add up to kind of like human level intelligence. And it's very tempting to believe that it must be, you know, it must imply that we're on the edge of kind of like human level intelligence, but that's not the same thing. You know, having programs that can do all those things incredibly well does not add up to human level intelligence.
Yeah, I mean, games are just a very well-defined, complex space that we want to search and we want to explore. And we've got algorithms that can do that very well. That is not the same as reasoning or thinking and arguing under uncertainty and, you know, the complexity of an interactive environment, not by any stretch of the imagination. even the complexity of the spaces, like AlphaGo was able to, they had to resort to Monte Carlo tree search. That was the big success. Nothing to do with the complex reasoning that humans or an actual intelligent avatar would be able to demonstrate.
Anything you'd like to add on our misconceptions, Rachel?
I'm going to go up a level and actually say, to me, it's, I think, a widespread misconception that bias is inherently worse in any AI technology than in how it was before, and I'll use quotation marks, or this idea that somehow humans can do better. And I'm just sort of reminded that the reason why we'd like to hand over so much decision-making to a non-human entity is that humans are terrible at making decisions without bias, right? And so it's not that I think AI is inherently better or worse, but sometimes I'm a little bit tired of the sort of incessant conversations that there's that you can't have AI without bias and increased inequality, and I think that's on us to improve as the drivers of technological change, but that humans have been historically terrible at doing well, at being nice or fair or even-handed in any situation, and that this actually reflects our desire to do better.
Right. And I think it comes back, though, to the point around, I keep banging on, and hopefully my colleagues in STS will be very proud of me, but I think that's the reason why we do need to have, and the Turing's great for this, having this discussion, debate, collaboration between various different kinds of people, whatever kind of social science, or citizen status they might be, in order to actually think about not just how are these systems built, how are they used, what applications, what stage are we at, but also to what extent do we want automated systems in these, or what kind of political change might we need in order for this to actually be utilised in a way that's useful, and so on and so forth. And I've been reminded a few times when I've been talking to people about issues with AI, in some sense you can argue that some of the advances in technology have done a good job of exposing some of the systemic issues that we have within society, but until we start to fix them, does it really matter whether we do it with humans or with machines? And I think that's in some sense a bigger question. I can't actually see the answer to this poll, unfortunately. Maybe the team could copy and paste and email me some of the cool answers. I've got my email open in front of me. That would be great, and I can hopefully read out some of what the audience thinks in terms of our most exciting discoveries. But let's move on to another audience question. Another one that got 18 votes currently, so clearly something people want to ask is from Mark Basham. Thank you, everybody, for submitting your questions. I'm not going to get to everything, but thank you for being so diving in with us. From Mark, do you think that the increases in costs associated with running big AI systems, energy, GPUs, etc., is going to outweigh the benefits and accelerate a possible bust? An interesting question. Who'd like to go first on this one? We'll go to you.
I mean, I think that's a very important question. It's a question that's not just related to large AI systems. Our weather forecasting compute requirements is almost at the same scale. So we definitely have questions to answer and to address regarding the energy requirements for high performance compute and distributed compute.
So it's an issue. I think what I would take a slightly different slant on it. I think Mark's absolutely right, but what this is telling us is that human learning is way, way, way more efficient than machine learning. Humans, the brain consumes about 20 watts of energy, and it's the best learning device that we know of. So what that tells me is that there is huge scope to increase the efficiency of machine learning technologies. They've got to get better. They've got to be able to use less data, and they've got to be able to use less compute power. So that, I think, gives us a grand challenge, I think, for where we should be going. We should be able to build these advanced machine learning systems without throwing global quantities of power and compute resources at them.
Yeah, I mean, I think that is the sobering point, how far away we are from anything resembling intelligence or artificial intelligence. 20 watts versus, I don't know how many.
Well, I think there was a famous experiment that, there was one machine learning system that was trained which required the electricity resources of, I think it was Gambia, to train. I mean, you know, that doesn't scale, right? I mean, there's a limit to what you can and should throw at these kinds of systems. So I think the emphasis should be on trying to make this a more efficient process.
So, it's interesting though to think, I mean, again, going back to sort of discourse, or lack of a better word, if you look at technologies like blockchain, that's one of the first things that people criticise blockchain for is energy usage. And you don't actually hear a discussion when it comes to AI as much, I would say, in the sort of general discourse around pros and cons. It is more to do with things like bias or use of data and inequity. So perhaps it's also more discussion required and more openness and honesty about the reality of what it means to build these systems. Do you want to add anything on this at this point, Rachel?
I agree completely with Mike. This is a case where I think, you know, pushing ourselves a little bit towards the unrealistic expectations is really important. And part of that is having the conversation. Yeah. Part of it is acknowledging that this is what's going on. Although I think, I think in sort of more analytical fields, people are fairly well aware of the analytical or energy requirements, I should say. But I really like the idea of like this being a challenge that we need to work towards. And
definitely. I've managed to get a few of these results through, so let me just share some of the results, although this is the most important scientific discovery from now until 2050, which is a different question, so maybe we could get the results from the previous one emailed over. That would be amazing. So before we do that, let's go back to the next question that we've got that's got another high number of votes. I'm not going for the top one, sorry guys. I think this looks like an interesting question. This is from Henry Seeley. What is the next milestone that you'll be looking for to gauge progress in AI? Interesting question, I think. Mike?
Yeah, no, I feel quite passionately about this. I want to see AI in the physical world, the real world. We've seen lots and lots of AI in software, like computer games being a classic example. And they're a great proving ground, but the physical world is very, very different. To put it in a techie way, the physical world does not come in neat data structures like you get in computer games, basically. So there is, I think, a lot of the techniques that have proven incredibly successful in computer games, like reinforcement learning. And reinforcement learning is basically where a program just tries things out and sees what happens. And that doesn't matter if you're playing Space Invaders. You know, if you get killed when you're playing Space Invaders, you just have another game of Space Invaders. It matters in the real world. You can't train driverless cars just by putting them on the road and letting them experiment, right? So the physical world is the next big challenge. And there are so many potentially beneficial applications of AI in the physical world. So I really want to see us make progress there.
Anything you'd like to add, Rachel?
Well, I'm not a fundamental researcher, so I think as a social scientist, we definitely are pushing to understand human behavior and preferences, but for me, the interesting point will be when we actually sort of understand how to nudge behaviors and what the impacts of nudging is, right? And this is, I think, where digital twins fit in, where simulation fits in, but it's not only understanding why we do the things we do and how we interact with our physical systems, our natural systems, our socio-political systems, but also when we need behaviors to change, how is that going to look and what's going to happen? Because that is super complicated.
Okay.
And I would completely agree. I think in the real world, and then what is really challenging is that socio-economic, socio-political area.
But what does it look like in terms of, the question was, what's the milestone? Because it's difficult to, it's a hard question, but it is hard to quantify. Arguably it's a bit of a weighted question. I would argue that sort of pseudo forms of measurement could be part of the problem with hype, right? Because if you say, we've managed to do this, therefore it works, But I'd be curious, is there something specific happening, some particular area of research? Is there some kind of goal, or is it a bit kind of, it works and then we look at it later? And do you see what I mean? How do you actually gauge that progress? Anything to add on that one?
Yeah, I'm going to be speculative. But so imagine, we've seen computer programs that can learn to play computer games very well. Just teach themselves completely from scratch, not knowing the rules, just teach themselves to play computer games very well. Imagine that we had a physically embodied AI system, a robot, that could teach itself to ride a bicycle, and the same robot that could teach itself to play a game of golf. Right? Two completely different physical activities. one of which I can do, the other of which I can't do very well at all, I have to tell you. But they're moving out from the software environment to the physical world. And I say the important thing here is, without giving it any advantage, just letting it train itself, just letting it teach itself how to do those things. That kind of challenge, I think, would be really exciting. And I would sit up and take notice if we could do that kind of thing.
Okay. Let's move on to another audience question. Again, I'm kind of just picking the ones that I think look really interesting here that we haven't touched on yet. Big word that I don't think any of us have said yet is trust, which is obviously really important and part of the discussion around AI. So, question from Max Griffiths: how do we engender appropriate trust? I think the word appropriate is interesting here in AI. You touched a little bit on these topics earlier, Rachel, so I'm going to go to you first.
Well, this isn't my area of research because I think I'm, as you probably have gathered, fundamentally optimistic about technology in general. But I think conversation, right? I think it's sort of having these dialogues where, you know, the shortcomings and the weaknesses are put out there, but then rather than discarding approaches, it's about sort of adapting to it and finding the workarounds. And that's a sort of, you know, more than a two-way street, it's a multi-way intersection, I think, of lots of different constituencies. But yeah, I mean, it's interesting that none of us probably really trusts. I mean, certainly if I pick up my phone, I don't trust my phone, but I'm still willing to engage with it. So I think an interesting avenue of conversation is, you know, we talk a lot about trust, but we still place implicit trust in a lot of technology. I mean, that's more than AI. So it's a very nuanced conversation about how we get to trust, because I think a lot of trust is already there.
And also in systems, right? I mean, you trust things like, I don't know, queuing in the UK, for instance, or certain areas.
We get on airplanes and we fly in them. And increasingly, although today may not be the best day to say it, but in general, flying is one of the safest things that you can do. Increasingly relies on automated decision making. And we still do it.
So flying is a very good example. So we've been talking about the fact that there is a lack of theoretical underpinning for deep learning, and therefore we can't trust it because we don't know what the failure modes are. The underlying fluid mechanics that keeps a plane up in the sky is still not fully understood. And yet we have, you know, regulators will pass the design of new wings and so on. And as you said, we don't even think about using aircraft. So it's quite an interesting one. So trust is quite nuanced. I mean, you could be very basic. The example that we spoke about telecoms and using filters, you know, to clean up signals. Only linear filters were used because the theory was understood. Non-linear filters were not trusted because we didn't understand them. So at that very basic level, that notion of trust, but then it's something that's you know, much more weighted in terms of the potential for disaster, something like aircraft flight. We still don't really fully understand the underlying theory.
I would argue, though, planes is a really good example. I mean, is it really about the technology, or is it about how it's built, who builds it, who's in charge? I mean, you only have to look at the recent Netflix documentary about the Boeing the 747 MAX, right? I don't know if any of you have seen it. It's a good documentary, but it's horrific when you watch it. The technology was, people knew what was wrong with it, so it wasn't really about the technology. It was about the systems by which it was regulated, the sort of business structures and plans and the way money's made and so on and so forth. So a lot of the time, I think sometimes we're focusing a little bit too much trust on the technology itself, as opposed to trust in terms of how it's built, who's it built by, what kind of incentives are being used in order to get these things to market, and so on and so forth. So planes is a great example in terms of highlighting that point around technology. However, it seems like the conversation is more about going back to it's the systems behind it. And maybe AI is there's too much focus on the specific tech and not enough around the systems around it. I don't know.
I mean, that's a great example, because we don't exist in a technology alone arena. It's a socio-technical arena that we work in. You speak about the biases of AI, but what about the biases of humankind? So that socio-technical aspect is incredibly important, and probably is really where we should phrase the narrative as we go forward, not just focusing on the technology.
anything you want to add on this
no,
point,
I
Mike?
think I think a lot of the issues that people are concerned about with AI arise at the interface between AI and people, and trust is just one of those. And what is a world where we are comfortable to interact with AI, which is embedded everywhere? And how should that appear to us? I mean, so one famous example, right, that arose when one of the big tech companies demonstrated that they had a version of their digital assistant that could phone up a restaurant and speak to somebody to book a table in the restaurant. But the point is that people in the restaurant were not aware that they were speaking to AI. And there was an uproar. And we quickly established a principle that actually, if AI is interacting with a human being, then the human being should be made aware that it's not interacting with another human being, that it's interacting with an AI. So that's one principle of very many potential principles, I think, that we need to figure out. What should the world look like when humans and AI are interacting with each other continually?
We're going to have one final question. We're going to reflect. We've got the poll results through, which was all about what do you think is the most impactful AI-related discovery in the past 10 years. So I want to share some of the ones that the audience put in. I think it's interesting to see what you guys feel is kind of most exciting for you. So we've got NLP here, generative models, GPT, AlphaFold, because it's the most significant AI contribution to the scientific community. Thank you for putting on why. Applications across disciplines, so things like nuclear fusion, protein folding, competitive coding, visual object recognition with deep learning. So lots here. So thank you for bringing that in, and I think goes back to the points earlier we were saying that there is actually quite a lot here that works and there's a lot to be optimistic about. I want to end on an optimistic framing of perhaps a pessimistic question, but I think is the best way to end this panel. Pessimistic framing, what's the biggest obstacle in the way of further progress? But optimistic framing, what do you think is the biggest challenge that we're seeking to overcome in order to get further progress for contemporary AI? Or a better way of framing it, what should all of us here and everyone in the audience be looking to try and solve if we really want to get the potential of AI off the ground as we move forward? I'm going to start with you, Mike.
Many, I think. If I had to pick just one, and this is something that Mark and I have been discussing quite a lot recently, it's reclaiming AI from big tech. When big tech is throwing global compute resources at an AI problem, that means that it's only accessible to a very, very small group. And so I would love to be in a world where AI was, really cutting-edge AI technologies were available to a much larger community.
Okay, Rachel.
Well, I've already touched on this. To me, it really is about the sort of human systems. I mean, from a sort of social science perspective, there's lots of work happening in transport or energy or mobility. But where I think the challenges lie for me is when those systems, these infrastructures, interface or come into contact with humans who are making interesting and not always predictable decisions and whose preferences and behaviors change over time. They're fluid, they're mutable. That to me is sort of figuring out, because that's the big challenges, right? There are challenges that we face are around climate and energy and inequality, right? We really like to tackle the grand challenges, and to do that we need the fundamental research. We need technology to be, I think, in common space for lots of people to access, but we really need to sort of sort out how we're going to use this to affect change.
Love it. Mark.
Well, grand challenges are not solved in 3-year cycles. Grand challenges take decades. And I think what Mike was alluding to, the big tech is making big bets and big sustained investments. And our governments need to be making those big bets. Well, they're making the big bets, and they need to be making the big investments in the research capability and the innovation ecosystem within, let's call it, the UK. So I would say that sustained long-term funding from the public sector, from government, in supporting the research and innovation in this space is absolutely essential.
Brilliant. One final question. We've got 3 minutes left on our timer. One final question that I just want to ask you is, what are you just most excited about right now? What are either something maybe you're working on, something you're seeing, or just an area of interest around AI globally that you think, do you know what, this is something that's keeping me waking up in the morning excited to go to work, or just generally why you still work in this space, why you still think it's worth being here. I'll start with you, Mark.
So the thing that's absolutely exciting for me in the role that I have at the Turing is that I think it's come out in the discussion that AI and AI technologies is not just focused on deep learning, but there are agent-based systems, there are planning, there's symbolic AI and so on. And all of that working together in concert is going to give us something far bigger, right? And so for me, pulling that together and pushing that forward, and the one place that it can be done in the UK is at the Alan Turing Institute. So this broadening the scope of AI research and AI innovation at a national scale is, for me, very exciting. So I won't geek out on you with the sort of techie things that I like, but more broadly, that for me is very exciting.
Brilliant. Rachel?
I have an answer similar to Mark's, that I'm interested in and very excited, I think, by how much is working in concert today in the time that we live in. It's partly the movements towards open science, which I think increases sort of the democratization of access to technologies and applications technologies, but it's also working across disciplines in ways that we never did before, so that you can have people who do the fundamental research, who know the very fine points of, say, AI, which I don't, but then you have people in their sort of domain specialties who can increasingly work together, and underpinning this, communities like research software engineers who help knit everyone together. I think this is a really nice time to be an analytical researcher.
Love it. And finally, Mike.
Yeah, I think it's, what I'm seeing is the way that AI is just being taken up across so many different communities. I mean, if I just go to my university, the physicists have discovered that machine learning can help them do things that they couldn't previously do, recognizing galaxies, the shape of galaxies, or processing pictures of black holes, or whatever it is. And it's suddenly giving them a new tool which wasn't accessible, almost in the same way that computers gave scientists a new tool. And so we're seeing this vast, flourishing period of these new ideas about applying AI and machine learning techniques absolutely everywhere in science, and also in the humanities as well, arts and humanities as well. I think that's just wonderful to see, and I think we're going to see a lot more of it over the next few years.
Well, Renaissance period.
Renaissance period. Well, speaking of what we're going to see over the next couple of years, the Renaissance period, all different examples from all different areas. Our next session is actually going to be starting looking at some of the spotlight talks where we get a bit of information from the researchers themselves around what they're actually doing. So join us in 5 minutes for our next session. But first, before we do that, please join me in thanking Mike, Rachel and Mark for a brilliant opening session. Thank you for giving us the view from the bridge and hopefully setting up brilliantly for all the sessions that are come to next on AIUK. Thank you very much for joining us. Thank you, guys.